Wow, this is awesome. This is awesome. Wow, 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 wow. You understand this now. I'm really proud of you on this. This is a very nice one. Okay, okay. Wow. The density is equals to mass over volume. We're giving the metal block of density 9,000 with 16 Newton in air. So you converted that. That's beautiful. Got the volume, equated it to that. Awesome. Then up thrust, giving you density times volume times gravity. Okay, your answer is actually Newton. Since they asked you to find the weight, so it has to be in Newton. Don't forget your unit. Very important. All right? Did you get that? Hello? Hello, are you there? When are you there?
Yes, sir.
Okay. All right.
Yes, sir.
Okay. That's a good one. I'm really, really proud of you on that.
Yes, sir.
Okay.
Yes, sir.
No problem. Okay. Let's solve another question now. Okay. Let's solve another question now. Okay. Can you hear me now?
Yes, sir.
Okay. The relative density, a relative, okay, take this. A relative density bottle weighs 20 grams when empty. A relative density bottle weighs 20 grams when empty. 80 grams when filled with water. 80 grams when filled with water. And 100 grams when filled with a liquid. And 100 grams when filled with a liquid. Find the relative density of the liquid. Find the relative density of the liquid. Okay, just try that now. Okay, the weight of the liquid divided by the weight of equal volume. Water, okay. If the density bottle weighs 20 grams when it's empty, 80 grams when filled with water, and 100 grams when filled with a liquid. So the weight of the liquid becomes 100 minus 100 minus the weight of the bottle, which is 20, and the weight of the equal volume of water, because when it is filled with water, becomes 80 minus 20. We know that this is 80 divided by 60, which gives us 1.33. Remember, relative density does not have a unit. Okay, that's exactly how you did yours, right?
Yeah.
Okay, let's solve this now. A density bottle has a mass of 0.04 kg. A density bottle has a mass of 0.04 kg when empty. a mass of 0.20 kg when some quantity of steel ball bearing is added to it.
So mass of what?
0.20 kg. 0.20 kg when some quantity of steel ball bearing is added to it. Is added to it. And a mass of 0.24 kg and a mass of 0.24 kg when the remainder of the bottle is filled with water. When the remainder of the bottle is filled with water. If the density bottle weighs 0.1 kg when filled with water, if the density bottle weighs 0.1 kg when filled with water, calculate the relative density of the steel ball bearing. Calculate the relative density of the steel ball bearing. All right. After this, now I'm going to give you an assignment. I'm going to give you your assignment. Sorry, have I given you assignment for chemistry? I didn't give you, right?
You said you were going to send.
Sorry?
You said you were going to send it.
Oh, I'm
You said
sorry.
you were going to send it.
That must be my fault. Okay, I'll send it after this class now. Let's do that now. Now, we know relative density, since we have mass now, relative density is going to be as the mass. The cell should calculate the relative density of the steel ball bearing. So we are going to have the relative mass of steel ball bearing, over the mass of water, the mass of steel ball bearing divided by the mass of equal volume of water, the mass of equal volume of water. Okay, now this is a complicated steel ball. Now the first said a steel ball, but a density bottle has a mass of 0. A density bottle, so the bottle, that's the bottle when empty. Let me just put bottle when empty. Bottle when empty gives 0.04 kg. Okay, a mass of 0.20 kg when quantity of steel ball bearing. Okay, now the bottle with steel ball, bottle with steel ball is equals to 0.20 kg. Okay, and a mass of 0.20. Remainder of the bottle is filled with water. Okay, bottle remainder with water. Okay, giving us 0.24 kg. Now they say if the density bottle weighs 0.1 when filled with water, okay, bottle filled with water, bottle filled with, oh no, bottle filled with water. Really? Why is this thing giving me like this? Okay. Coming. Bottle filled with water gives us 0.1 kg. The question is, calculate the relative density of the steel ball bearing. Good. Before we calculate the density of the steel, the mass of the steel ball bearing. Now, we have to get the mass of the steel ball bearing. Now, bottle when empty and bottle with steel ball. So the mass of the steel ball bearing will be what? The mass of steel ball. Let me do it downwards so that we have space. Okay, mass of steel ball For us to get the mass, the mass of steel ball will be 0.2 minus 0.04, isn't it?
Yes.
Because this has steel ball and this is when empty. That becomes 0.2 minus 0.04. And what would that give us?
$0.16.
Okay, 0.16 kilogram. All right, we've gotten the one. Now let's look for the mass of equal volume of water. For us to get the mass of equal volume of water, so many things is happening here. We need to get the mass of water filling the whole bottle. The mass of water. Now, we need to get the mass of water. Look at, this is when the bottle is filled with water. Now, this is when the bottle is empty. So we need to get the mass of water. We need to get, number one, there are two things we need to get here. Number one, the mass of water filling the bottle. And we're also going to come to this bottle remainder with water. So the mass of water filling the whole bottle. The mass of water filling the bottle, filling the whole bottle okay, that will give us 0.1 minus 0.04 kg. What would that give us?
0.06 kg.
0.0 what?
6
kg. Okay. Now, if we have done this now, they said the bottle remainder with water and the same bottle with steel ball. Bottle remainder with water. Now, we still need to get the mass of this water. Remember, we need to get the mass of this water here. When they said the bottle was remaining with water and the bottle with steel ball. So that the bottle remaining with this, that is this remainder water, would be, for us to get this mass, the mass of this water here, because this mass here is the mass of the bottle and the water. But now we need the mass of this water. That would be, the mass of this one will be 0.24 minus 0.20. Do you understand that?
Yes.
Okay, so the mass of remainder water okay will become 0.24 minus 0.20, and that gives us what? That gives us what?
0.04.
0.02 kg. Okay, let's now look for the mass.
0.044.
Okay, 0.0 what?
4.
Okay, 4. Okay, let's look for the mass of the mass of water now. The mass of water. Let's look for the mass of water. The mass of water becomes 0.06 minus 0.04, which will give us 0.02 kg. Okay, now if this gives us 0.02 kg, that becomes the relative density. Relative density becomes, okay, relative density becomes the mass of the steel ball. 10 minutes. Relative density becomes the mass of steel ball. And what's the mass of steel ball? 0.16 divided by the mass of water of equal volume. The mass of water of equal volume, okay, that's 0.02. And that gives us what? 0.16 divided by 0.02. Sorry?
8. 8.
Yes, 8 kilogram. Okay.
I thought your relative density does not have any.
Oh, sorry. That I thought we were calculating mass. I'm sorry. That's 8.0. Okay. Yeah. So that is it. Now, have you written that down?
Yes.
Okay. Take this assignment down, please. The relative density of ice is 0.2. The relative density of ice is 0.92. 0.92. What fraction of the volume of a piece of ice? What fraction of the volume of a piece of ice? What fraction of the volume of a piece of ice will be submerged? Will be submerged in A, water, B, a liquid of relative density 1.11, a liquid of relative density 1.11, in brackets, take the density of water as 1 gram per centimeter cube. Take the density of water as 1 gram per centimeter cube. Okay? Number 2. A 2 centimeter cube sample of a tin lead alloy. A 2 centimeter cube sample of a tin lead alloy has a mass of 18 grams. Has a mass of 18 grams. If the density of tin is 7.3 grams per centimeter cube, if the density of tin is 7.3 grams per centimeter cube, and that of lead is 11.4 grams per centimeter cube, and that of lead is 11.4 grams per centimeter cube, what fraction by weight of the alloy is tin? What fraction by weight of the alloy is tin? Assume there is no change of volume. Assume there is no change of volume when the metal form the alloy. When the metal form the alloy. Okay. Have you gotten that now?
Yes.
Let's pray then. Father, we thank you for today, for your mercies. Thank you for wisdom. Blessed be your holy name, Lord. In Jesus' name.
Amen.
All right, no problem. Have a wonderful time. I would send you the chemistry there.